In this lecture, we'll start from these cookies. What cookies can be used for? Those can be used for authorization, shopping carts, and recommendations. Sometimes user session state. For example, web email, we can use these cookies, but in advance, this cookie is not recommendable, even though this one is providing excellent customized service. Because of the security issue, this one is not recommended. How to keep state? There's no way to keep state, so we can use this cookie instead. Protocol endpoints need to maintain state at sender and receiver over multiple transactions. These cookies can carry state, and under HTTP messages, the cookies can be used, and in the client side, the cookie can be stored there. And in terms of the programmer's perspective, for example, JavaScript in the client side, there is object, and that object can handle cookie. That is cookie object. Also in the web server side, for example, ASP, JSP, there is cookie object. Thus we can take care of cookie to the programmer's point of view. We can handle. In terms of the privacy or security, this one is explaining about some important issues about that privacy. Cookies permit sites to learn a lot about you for customized service that can be used for good purpose. You may supply name and email to sites. Another issue here explained, web caches. This cache is a kind of memory and a little bit faster speed. For example, proxy server can be used for accelerate the speed. Let's look at this one. Goal is to satisfy client request without involving origin server. Here we can think this one is the origin server and this one is client. Even smartphone can be used as client here. And user says browser, web access is via cache. For example, here, user. We can directly connect to the server to get some information. But sometimes we are using this proxy server. The main purpose is to the speed better, to make the speed better. Browser sends all HTTP requests to cache, and this one is storing that information temporarily, and if that is required, then it is providing instead of that server. Object in cache. Cache returns object. For example, JPG image and other object can be returned instead of this origin server. This one is providing that. There's the speed will be up. If that is not stored there, that means else. Cache request object from origin server. Then this one is requesting here the object from the server, and after that will be stored there. And later, if another clients are asking about that object, then this one is providing that stored object. Okay, this one is some other aspects about the web caching. Cache acts as both client and server. As we observed already in the previous slide, let's go back here. This one is providing. In that case, this one is working as a server. If this one is not having that object, then this one is requesting as a client, then this one is running as a client. In that sense, it is working as a client as well as a server. Thus, cache acts as both client and server. Server for original requesting client and the client to origin server. As I mentioned, this one is working in both ways. Typically, cache is installed by internet service provider. For example, university, company, or residential internet service provider is providing that cache server or proxy server. Why we need this web caching? To reduce response time for client request, to increase the performance, to improve the performance. We can reduce traffic on an institution's access link. Thus, we can reduce the traffic. Thus, we don't need the higher speed bandwidth, then it will be related to the expense of that institution. Internet dense with the caches. This one is enabling poor content providers to effectively deliver content. Also, this one is working in that way in the P2P file sharing architecture. Here, how it is improving the performance. Let's look at this simple example. Assumption. Let's assume average object size is 100K bits, and average request rate from browsers to origin server here, browser here, and that is requesting 15 requests from this browser to the origin server to get this object. Average data rate to browser, this one is 1.5 megabps, and the round trip time from institutional router to any origin server, this is institutional router, and let's assume it will take around 2 seconds. Access link rate is 1.54 megabps. Here, instead of the institutional router here, the speed, the delay time from here to here, let's try to make it simpler. Then the total delay time, round trip time, will be the summation of this one and this one and this one. Then we can understand after some analysis. Okay, consequences. LAN utilization 15%, because this one is 1 gigabps, and this LAN is utilized 15%. And access link utilization, this is almost fully utilized, because this is every data rate to browser 1.5 megabps, and this is almost 1.5. That is actually 1.54. That's around 99%. And total delay, as I mentioned, this delay, and this delay, we add up together: internet delay and access delay. Access delay means here, and the LAN delay, that is negligible because that is so small. Usually that is here 2 seconds here, round trip time, delay time, and here usually it will take longer time, minute, and this one is usually microsecond. Thus that is almost zero, negligible. Thus this one is the bottleneck link. Thus, how to improve the whole round trip time? This one is almost fixed, constant, and this one is almost negligible. Thus, we need to reduce the round trip delay time here. That is called excess delay. And this bandwidth is being used to reduce that excess delay. If that is higher speed, then the excess delay time that will be short. But if it is too slow or narrow bandwidth, then it will take a longer time. Thus, as I mentioned, this one is the problem. Thus, we can improve in this way. First, better access link or faster access link. Both words can be applied here. Assumptions. Average object size, those are same. And average request rate, every second 15 times. The request frequency is 15 times every second. The average data rate to browser 1.5 megabps. And round trip time from institutional router to any origin server, 2 seconds. Let's assume this one is for that. And access link, we can improve 100 times higher speed than this. That may be good to improve the speed, to improve the performance. The result, consequences here. LAN utilization, that will be drop a lot like this. That is simply a 15 second, every 15 second, 15 requests. There's average data rate to browser. If we multiply this one and divide it to this one, then that will be below 10%. That will be lessened in that way. Thus, that is not utilized fully. That means the speed will be up. Comparing to the previous slide, this one is not busy. Thus, this speed will be up. Access time, access delay will be shorter. That will be reduced. The total delay, as we did already in the previous slide, we can add up together this one and this one, and also this one. This one is always almost negligible, and this one is reduced. Instead of this minutes, the unit will be like this millisecond unit. Thus, we can add up together. Thus, this one is almost a constant fixed value. Thus, 2 second round trip delay time, response time, that will be sufficient enough. Thus, we can improve the speed in this way. The problem is this one is so expensive. To get higher bandwidth, we need to pay. Expensive, we need to use expensive bandwidth, and we should pay to the internet service provider. Like this, cost, increased access link speed, not cheap. That is very usually expensive. Thus, another way we should consider, let's assume almost the same, and consequence LAN utilization 15%, and let's assume simply we are running conceptually. Thus, instead of detailed analysis here, we can get some general and brief idea here. If this one is bottleneck link, then we can reduce in that way, like previous solution. But the problem is this one is very expensive if we are improving the bandwidth. We need to find out other way, other solution. That is the solution here. We are using local web cache, that is proxy server in other words. And how to compute the link utilization delay. And let's move to the next. Conceptually, we learn calculating access link utilization delay with cache. suppose cache hit rate is here. We need to consider hit rate. Hit rate means if we want to find something from this server locked in this LAN, if that is stored there, then we don't need to go out to get information from the origin server. That is called hit. If that is not here, then that is called miss, and the percentage of that is called miss rate. Here, suppose cache hit rate is 0.4. That means whenever we are trying to get 10 times, then almost 4 times we can get that right object from here. 60%, that means among 10 requests, another 6 requests that should be serviced by this server, and we should get that information from this origin server. 40% request satisfied at cache here, and 60% request satisfied at origin here, origin server. Access link utilization. Here the traffic that is reduced because whole traffic 100%, among 60% will go out, 40% will be here, because 60% those requests is that is in failure, they should go out. This access link will be busy because of that. That means 60% of requests uses access link. The 60% among these, and that will be like that. Then full bandwidth, we are dividing this, then utilization is like this. There's total delay, as we calculated already in the previous slide, but here we should consider the probability. The whole probability is 100%, but here we should divide into 2 groups. One is missing rate 0.66%, 40% that is successful, that is called hit rate. And if we are going out to get the object from the origin server, then how long does it take? And that probability is 60%, thus we should multiply to this. This is a kind of random process, and this is a kind of probability calculation. In this way we can roughly calculate the whole access time, whole average response time in this way. Later I will explain additionally on the whiteboard, but here we are trying to understand it this one, but it simple and conceptual idea we are trying to understand. And let's think about this delay time from origin server. It is the delay time if we are trying to get the information from here, then access here. The delay time here 2 seconds, as we used already in the previous example. And it will be like this. The other this one is negligible. This one is like this 0.01. That means that is 10 millisecond. And you don't need to worry about this one. Thus, instead of this one, you can simply 2 seconds, and that is multiplied with this 0.6, and we can add up together with the result of this 0.4. This one is almost negligible, thus we can eliminate this one. There's roughly, and we can calculate, we can derive this value 1.2 seconds. In this way we can improve the response time. Instead of the previous 2 seconds, even that for that bandwidth, higher bandwidth, comparing to that higher bandwidth, this one is much better. Previous delay time was 2 seconds after improving 100 times. the bandwidth time, bandwidth, and the cost will be very expensive. But here we are using instead this local web cache, and this one is not expensive, and also we can use always. But previous case, if we are using this higher bandwidth, then every month we should pay a lot of money. But this one is cheap comparing to the previous bandwidth, and usually personal computer and those performance is so good, thus we can use the higher performance personal computer even that can be used here. Depending upon the institution's capability of carrying their computers in that organization, the cache server or proxy server, that performance will be different, and also the price will be different. But usually this one is cheap comparing to that higher bandwidth. People meet me then probably in the 7th week when I am introducing some solution. Then I will explain some additional comments to understand better. Okay, let's move to the next. Okay, another thing to think about this cache server or proxy server. Here, this one is also related to the Wireshark lab. Here, conditional get. What is conditional get? Let's think about this client and the server interaction first. This client is requesting HTTP request message, and this one is checking if modified since some date to differentiate from the contents. If this one is still having that information and that is not changed yet, and we need to some way to find out, this one is the way. If modified since date and the object not modified, this one is if modified since, that means that object is not modified. Instead of this before, or after, it will be proper. After certain date, if that is not modified, then we can use that same contents because that is modified after certain date. Okay, let's follow others. Okay, let's look at this one first. Goal is we don't send a server, don't send the object if cache has up-to-date cached version. The cache, the buffer, this one here, you can think the buffer instead of cache memory, a cache server, because the cache buffer that is being used here in the client, also even in the cache server or proxy server. Here, let's make it simplified, just two client and the server interaction between them. Only that interaction we are considering, then we can understand better. The object transmission delay and the lower link utilization, that those are main goals why we are using this conditional get to check whether that is being modified or not. Cache, this one is specifying date of cached copy in HTTP request. Thus here, if we are considering the cache in this client device, then this one is specifying date of cached copy in HTTP request. Also, this request you can observe in the Wireshark lab. If modified since, that is not changed after this date instead of this before, after date, then we can use the same contents stored here because that is not modified. And the server is considering the modification depending upon that given date, and if that is modified since that date, then it is sending new updated data to the client. Let's look at this one first. Server response contains no object if cached copy is up to date. There's this one. This one is still explaining about this one. If that is not modified, then server is not sending that object. Simply this one is sending this one, HTTP 304 not modified, simply instead of the long and big contents. But in other case, if that is being modified after that date, then HTTP request after receiving this if modified since that date, and this one server is checking whether that is being modified or not. Object is modified after that, then that updated, new and modified that object will be sent to the client. Because that is being modified, the client's object is obsolete and the old one, the new one, should be provided. Thus HTTP response, HTTP 1.0, that is version number, 200, that is successful, okay, and the data will be following. Thus this one can be the web page HTML data. Thus we can get updated information on the screen. Okay, let's move to the other subchapter. This one is explaining about the email, and this SMTP, POP3, IMAP, those are related to this email application. Email, we are using almost every day, thus we are very familiar to this email. Thus let's look at some key points. Three major components to use email: user agent and the mail server and the simple mail transfer protocol. Thus here user agent, that can be software application program taking care of that email, and here user agent, your computer or smartphone can be user agent, and to use email you are using some software that is called user agent. And here user agent, here also known as, or in other words we can think, or mail reader. We can compose, edit, read mail messages, and for example as a user agent, Outlook and the Thunderbird, iPhone, mail client, those are all a kind of user agent. And outgoing incoming messages stored on server, and this is called the mail server. And between mail server, they are using SMTP protocol. This SMTP means Simple Mail Transfer Protocol. This one is using TCP. Here let's look at this one, outgoing message queue here, and this is user mailbox. Still we are learning about the email, mail server. Mail server's mailbox contains incoming messages for user here, and message queue of outgoing mail messages, and the SMTP protocol using those mail server and the SMTP protocol we can send and receive email. SMTP protocol can be used between mail servers to send email messages. Client is sending mail server. A client is sending mail server, and the server is receiving mail server. Thus this mail server can work in both ways. As client, this one is send. As server, this one is receiving. Email, that protocol name is SMTP, and you don't need to worry about this one, and you don't need to memorize this one. Further standardization during standardization activity, that is the code name for that, but at this moment you don't need to worry about that. We are using the standards every day, and this one is important. The port number is 25. To differentiate between applications, we need to use, as we learned already, identifier instead of the IP address. Also using that IP address, and moreover the port number that will be used. Those are called the socket number, and we can differentiate different applications with this port number and IP address. Uses the TCP to reliably transfer email messages from client to server. Port number, you should memorize this on 25. That is worldwide standard. Direct transfer, sending server to receiving server. And the three pages of transfer, handshaking and transfer of messages, and after that finishing closure. This one is like working like HTTP command response interaction. Command that should be based on ASCII text, and response is status, code, and phrase. And messages must be in 7-bit ASCII. ASCII, that is called ASCII code, American Standard Code. Scenario, let's look at this example. Alice here, and she's trying to send email to Bob. Here, let's look at and let's follow this procedure. Alice uses user agent to compose a message mail program in this computer, and she's sending email to Bob. Alice's user agent sends message to her mail server, and message is placed in message queue. A client side of SMTP opens TCP connection to Bob's mail server. This is Bob's mail server, and we are using TCP because SMTP is using TCP. There's a TCP protocol is first, that is establishing the connection, and after that SMTP client sends Alice's message over that opened established TCP connection. And Bob's mail server places the message in Bob's mailbox here, and Bob invokes his user agent mail program to read that message email. And this one is another example how that those are interacted between them. This is interaction, SMTP interaction. Long time ago we used in this way, but better graphic user interface and better interface we can use in very convenient way the email every day. But long time ago it was so bad in terms of user interface. Thus we should provide some command line and to use internet and to use email, and in this way, for example, internally that may be working in this way, but we don't need to worry about that. Just for reference. Okay, try SMTP interaction for yourself. As we did already in the previous HTTP example, that was the port number was 80, and we can emulate or simulate the telnet HTTP. We can simulate HTTP using Telnet, and here we can do similarly for this SMTP interaction. And this is just for reference, and in this way we can do that, but we don't need to use that. Because without using email client, that software we are using, very convenient software we are using. Without that software, long time ago, we used in this way, but we don't need to worry about that. This one is finalizing world. SMTP uses persistent connection and TCP connection, TCP protocol. SMTP requires message to be in 7-bit ASCII code, and SMTP server uses carriage return line feed, carriage return line feed twice to determine end of message. Long time ago, when we are using email command line interface, we used in that way. Every command should be typed in, but email software is so convenient, even by smartphone or by PC. Thus we don't need to worry about this one anymore. Comparison to HTTP. If we are comparing to the HTTP, then HTTP, for example, web service, we are trying to pull from the web server, and SMTP, we are trying to send something. When we are sending something, then this is a kind of pushing. Both have ASCII command response interaction status codes, as we learned briefly in the previous slides. HTTP, each object encapsulated in its own response message, and SMTP case, multiple objects sent in multi-part messages. Here, mail message format. Also, this one is just for reference. SMTP protocol for exchanging email messages, header and the body. This is the request for comments, and this one is standard RFC code for that email. Text message format. Header line to from subject, and that is a little bit different from SMTP mail from receipt to comments, and this is just for reference. And the body, the message, that should be ASCII characters only. Okay, let's focus on this one. What kind of protocols are being used here between this client and this server, and also client and server, and between this server, user agent. This one is using SMTP to deliver some message to receiver server. Also, this one can use HTTP. If we are using webmail, then HTTP protocol can be used. Instead of this SMTP, we can use HTTP also. There's, if we are considering these other protocols, between these servers, we are using SMTP. And here, trying to get that received mail, here, mail access protocol. What kind of protocols are being used here to retrieve from the server? Bob is using POP. Bob's user agent is using POP. That is simple protocol, and the full name is post office protocol. comparing to this IMAP, this is Internet Mail Access Protocol. This is a little bit more complex and more convenient because this one is providing more features, including manipulation of stored messages on server. And the HTTP protocol can be used. For example, Gmail, Hotmail, and other mail program we can use HTTP webmail service. We are using this one. Among them, let's look at this POP3 protocol. Here, authorization phase. First, server is ready, and this is server client. This one is checking whether the server is ready or not. This is called authorization phase. Client commands, user declare username and password, those are typed in, and the server response OK. And if that is wrong, an error, that is not OK, then not successfully logged in one. And transaction phase. After that, client is sending list message numbers and retrieve message by number and delete, queued, and so on. We don't need to worry about this one. Long time ago, before introduction of the convenient mail program, we used this line by line command to use Ethernet, to use email. Long time ago we used this line by line to use email, but we are using very convenient email program, thus we don't need to worry about this command line. Each command line, we don't need to worry about that. POP3, a little more about that, and the IMAP we can compare. More about POP3. Previous example uses POP3 download and delete mode. There are two modes. One is download and delete mode, and another one is download and keep mode. First, let's look at this one. Download the email contents to my PC. After that, that will be deleted in the server. That is called download and delete. POP cannot delete email if he changes client. Thus, in the server, that is not, the email is not there anymore. Thus, with other computer, that cannot be read because that is not existing anymore, because that is deleted. And only that the first computer which accessed the first time, that is storing that mail. And with the other computer, if we are changing our computer, then we cannot access that email anymore. And if we are using download and keep mode, then multiple copies, same email is stored in this PC. If we are using other PC to download that email, then in that PC that email contents are still there. Those copies are stored in many different clients. And POP3 is stateless across sessions, and IMAP. This one is keeping all messages in one place as server. Thus it is more convenient because with other device we can access in the same way. Allows users to organize messages in folders. Also we can use folder, and keeps user state across sessions. Names of folders and the mappings between message IDs and the folder name we can manage better, and that is providing more features, more convenient features, and more complicated software.